Right here, we're going to look at probabilities of compound events on Khan Academy. The tricky thing about this topic is that for a lot of these problems, we're going to need to draw some kind of tree diagram to show the sample space. If you flip 3 fair coins, what is the probability that you'll get at least 2 heads? Well, if we flip 3 fair coins, there's going to be 8 possibilities. First flip, we could get heads and tails. Second flip, we could get heads or tails again. And on the third flip, we can also get heads or tails. This bottom row of the tree diagram shows all 8 possibilities. And the question says, what is the probability you'll get at least 2 heads? So at least means could be 2 heads or 3 heads. So here's at least 2. Here's at least 2. Here's at least 2. Over here, if you get a tails on the first flip, the only way you're going to get at least 2 heads is heads on the next 2 flips. So 1, 2, 3, 4 out of 8, or 1/2. You're at a clothing store that dyes your clothes while you wait. You get to pick from 4 pieces of clothing and 3 colors. If you randomly pick the piece of clothing and the color, what is the probability that you'll end up with socks that aren't blue? Well, there's going to be 4 outfits with purple socks, 4 with blue socks, and 4 with orange socks, right? Because we have shirt, pants, socks, or hat. Let's back up. I didn't notice it said socks there. So we have a shirt, pants, socks, and hat. Each of those comes in 3 colors. Purple, blue, or orange. So we are going to have 12 possibilities. So you can see I got thrown off when I tried to jump right into the answer and not draw the diagram. Once I have this diagram, it's a lot clearer to me what the question is asking. What is the probability that you'll end up with socks that aren't blue? Well, here's the socks, and there's 2 socks that aren't blue, purple and orange. So that's 2 items of clothing out of the 12 total, which is 1/6. If you roll 2 fair 6-sided die, what is the probability that at least 1 die shows a 3? Well, the first thing we'll do is write out the numbers 1 through 6 to represent the first die. And if I drew the trees, I can see that there's going to be 36 options, 6 times 6. So let's just draw out all the possibilities where we get at least 1 3. So we could get a 1 and a 3, 2 and a 3. This one we've already rolled the 3, so all 6 of these will work. If we roll a 4, 5, or 6 first, we need a 3 on that next roll. So we got 1, 2, 8, 9, 10, 11. 11 out of 36 is the probability. All right, last one. You've decided you want a plant for your room. At the gardening store, there are 4 different kinds of plants and 4 different kinds of pots. So 16 possibilities, 4 times 4. That's the fundamental accounting principle. If you randomly pick the plant in the pot, what is the probability that you won't get a clay pot or a cactus? Well, again, if we draw out the tree diagram, it's going to make it way easier to answer this question. We have a tulip, fern, cactus, and a ficus. And we have 4 different kinds of pots: clay, plastic, metal, and wood. So I'll write out clay, plastic, metal, wood for each of these. If you randomly pick the plant in the pot, what is the probability that you won't get a clay pot or a cactus? So we can't get this. Cactus. We can't get a cactus. We also can't get a clay pot. So we can't get a tulip with a clay pot, fern with a clay pot, or ficus with a clay pot. So what's left for us? We can get a tulip with one of these 3 pots, a fern with one of these 3 pots, or a ficus with one of these 3 pots. That's 9 possibilities out of 16.